Our universe is a magnificent tapestry woven from countless galaxies. These galaxies come in various shapes and sizes. Some are immense, spanning millions of light years, while others are small and delicate, like faint starlight in the night sky. Today, we embark on a journey across the cosmos to explore 10 of the most iconic galaxies. May this video wash away the fatigue of your day. Are you ready? Let us set sail on this interstellar adventure spanning billions of light years. In an instant, we transform, traversing millions of light years. First, we arrive at the Andromeda Galaxy, located about 2.54 million light years away. Andromeda is the closest large spiral galaxy to the Milky Way, with a diameter of approximately 120,000 light years. It contains countless stars, at least 1 trillion, several times more than the Milky Way. Andromeda is renowned for its elegant spiral structure, featuring a bright galactic bulge and spiral arms. Its core is active, hosting a supermassive black hole with a mass of about 140 million suns. In the early 20th century, Andromeda was thought to be a nebula within our galaxy. It wasn't until 1926 that Edwin Hubble, by observing Cepheid variable stars in Andromeda, proved it was an independent galaxy beyond our own. This discovery fundamentally changed our understanding of the universe's scale, revealing that countless galaxies exist beyond the Milky Way. Current observations show that Andromeda is approaching the Milky Way at about 110 kilometers per second and will collide with us in about 4 billion years. Gravitational interactions will cause repeated passages and mergers, and after 7 billion years, a giant elliptical galaxy will form. After leaving Andromeda, we now arrive at the Sombrero Galaxy, located in the constellation Virgo, about 29 million light-years from Earth, with a diameter of 90,000 light-years. It is famous for its distinct dust ring and bright bulge. From Earth's perspective, the Sombrero Galaxy is tilted at just 6 degrees, making its dust band particularly prominent. Its appearance resembles a Mexican sombrero, hence the name. The central bulge consists mainly of older stars, emitting bright white light. At its core lies a supermassive black hole with a mass of about 1 billion suns. The surrounding dark ring is composed of cold atomic hydrogen, gas, and dust, a primary site for star formation. Leaving the Sombrero Galaxy, we now journey to the Pinwheel Galaxy. This face-on spiral galaxy is located in Ursa Major, about 21 million light-years from Earth, with a diameter of 170,000 light-years. The Pinwheel Galaxy's most distinctive feature is its broad, asymmetrical spiral arms. Scientists believe this may be due to interactions with a companion galaxy, where tidal forces have shaped its complex structure. Its arms are filled with H2 regions and dense molecular clouds illuminated by young, hot stars that create a mesmerizing glow. Within these molecular clouds, gravitational collapse continuously forms new stars, making this a stellar nursery. Next, we arrive at the Cartwheel Galaxy, located in the constellation Sculptor, 500 million light-years from Earth, with a diameter of 150,000 light-years. It is renowned for its wheel-like structure, a stunning outer ring, a bright inner ring, and a central core connected by spokes. The outer ring, about 100 light-years in diameter, is rich in young, hot stars and H2 regions, making it an active star-forming area. The inner ring, 50,000 light-years across, contains older stars and less gas, with weaker star formation. The spokes connect the two rings. Scientists believe this unique structure resulted from a galactic collision about 100 million years ago, which triggered gravitational effects and density waves, redistributing matter and forming the extended outer ring. The Cartwheel Galaxy is a classic example for studying galactic collisions and ring formation. Leaving the Cartwheel Galaxy, we now visit Hoag's object, located in Ophiuchus. about 600 million light-years from Earth, with a diameter of 120,000 light-years. It is a rare ring galaxy, with around 8 billion stars. Hoag's object consists of a bright central bulge and an almost perfect ring. The core, 17,000 light-years across, is composed of older red stars in a spherical shape. The ring, 120,000 light-years in diameter, is made of young, hot blue stars and is a star-forming region. There is almost no material connecting the ring and the core. The formation of Hoag's object remains an astronomical mystery, challenging traditional theories of galaxy formation. Some scientists suggest it may have formed when a smaller galaxy passed through a larger disk galaxy, creating the ring structure. Next, we arrive at the Mice galaxies, located in Coma Berenices, about 190 million light-years from Earth. This is a pair of colliding spiral galaxies, whose gravitational interaction has formed long tidal tails, resembling a mouse's tail. The western tail stretches hundreds of thousands of light-years. Scientists estimate the collision began about 160 million years ago, triggering intense star formation, especially in the tidal tails. Over the next billion years, the two galaxies will continue to merge, eventually forming a giant elliptical galaxy. The Mice galaxies are a classic example for studying galactic mergers. Leaving the Mice galaxies, we now visit the Antennae galaxies, located in Corvus, about 45 million light-years from Earth. This pair of colliding galaxies, NGC 4038 and NGC 4039, have similar masses, each containing tens of billions of stars. The collision began about 1.2 billion years ago, and gravitational interactions have drawn their stars, gas, and dust together, forming bridge-like structures, and long tidal tails extending hundreds of thousands of light-years. These tails consist of millions of stars and vast amounts of gas. The cores will continue to approach each other, eventually merging into a new galaxy. Next, we arrive at ARP 273, located in Andromeda, about 300 million light-years from Earth. This interacting pair consists of the spiral galaxies, the larger UGC 1810 and the smaller UGC 1813. ARP 273 resembles a cosmic rose, its unique appearance resulting from gravitational interactions. UGC 1810's gravity has stretched and distorted UGC 1813, creating spectacular tidal tails and bridges. Scientists believe UGC 1813 may have passed through UGC 1810, intensifying the distortion. Their dance will continue for billions of years, and in about a billion years, they will merge into a larger galaxy, leaving ARP 273. We now visit the Black Eye galaxy. This spiral galaxy, located in Coma Berenices, is about 17 million light-years from Earth, with a diameter of 55,000 light-years, slightly smaller than the Milky Way, and contains about 10 billion stars. Its most striking feature is a broad dark dust lane, obscuring the bright central bulge, resembling a black eye. This dust lane consists of carbon and hydrogen particles. The Black Eye galaxy's inner and outer disks rotate in opposite directions. A unique characteristic, the inner disk rotates clockwise at about 300 kilometers per second, while the outer disk rotates counterclockwise. At their intersection, gas collisions compress material, triggering intense star formation and creating bright H2 regions that glow pink under the light of young stars. Finally, we arrive at the Cigar galaxy. This starburst galaxy, located in Ursa Major, is about 12 million light-years from Earth, with a diameter of 37,000 light-years, smaller than the Milky Way, but 5 times brighter, with a core region hundreds of times more luminous than our galaxy's center. The Cigar galaxy is the second largest member of the M81 group after its neighbor Bode's galaxy. The two are only 750,000 light-years apart, forming a striking pair in the sky. The cigar galaxy has an elongated elliptical shape, resembling a cosmic cigar. Its core is extremely active, with young stars forming at 10 times the rate of the Milky Way, lighting up the galaxy's blue disk and red hydrogen jets. This starburst activity began about 100 million years ago, triggered by gravitational interactions with Bode's galaxy. Tidal forces compressed interstellar material, leading to massive star formation. The collision also created bipolar jets of hot gas and dust, extending thousands of light years vertically from the disk. The cigar galaxy is a classic example for studying starbursts and galactic interactions. At this point, our interstellar journey comes to an end, from the magnificent spiral arms of Andromeda to the starburst frenzy of the cigar galaxy. These 10 galaxies showcase the diversity and dynamic beauty of the universe. They are not only subjects of astronomical study, but also symbols of humanity's spirit of exploration. Through this journey, we have witnessed the birth, collision, and evolution of galaxies, processes that remind us the universe is a constantly changing stage. At the same time, we marvel at the vastness of the cosmos and reflect on how small and fragile we humans are.